Hi everybody, welcome back to class. Today what we're going to be doing is going over the last little section of our notes for matter, which is volume. So remember the first part of matter was mass, and mass is the measure of the amount of matter in an object or substance. Now we're looking at volume, which is the second part of matter. And volume is the measure of the amount of space an object or a substance takes up. So now we're looking at the amount of space. How much space does it take up, basically? How much area? Where does it occupy? Is another way to say it. Now, you're used to measuring volume. In English units. And the English units of volume are the cup, the pint, quart, gallon, fluid ounces. You also have tablespoon, teaspoon. So there's a lot of these. There's a good many units for just measuring volume alone, and it all depends on the amount that you want. But we're not going to be using those really anymore this year. What you're using are the metric units. And the metric units for volume are going to be cubic meters or cubic centimeters, or we're going to be using liters and milliliters. So there's only really four. And the ones that you are most commonly going to be using in this class again and again and again will be the cubic centimeters and the milliliters. Liters and cubic meters you may use slightly, but we won't be using them as much. You will be converting. So when we're looking at the units, you're usually going to use cubic centimeters and milliliters are what you're most likely going to be using. And the reason that it's so easy to use this is 1 milliliter equals 1 cubic centimeter. So every time you have a milliliter, it equals a cubic centimeter, which is nice because now I can convert as it said here, the volume of liquids is in milliliters and liters. So I can convert the volume of a liquid into a volume, what I would use for a solid, because cubic centimeters is length times width times height, and that's usually used with solids. So we can know how much liquid is going to go inside of a solid container because of this conversion. So if you have 40 milliliters of water, it can fit in a 40 cubic centimeter container. Everything is a 1-to-1 ratio there. Now, milliliters and centimeters are going to be for small volumes, typically. Liters and cubic meters are going to be for larger volumes. In liters, you're typically used to seeing the term liters in a 2-liter bottle of soda. Now, I don't have a 2-liter bottle here, but we do have a picture of the 12 fluid ounces, or 360 milliliters. So we do have that here. We're going to go here. So we have 12 fluid ounces, which are your English, and you have 360 milliliters, which is your metric. And that's where you normally see them used on liquid containers. You'll see them one time there on the back. You'll also see them up here on the front, showing you how much the volume is in each one. But with metric, you also have the masses on the back here again, just so you can see that, yes, they do not go away. You do see them. You do have the metric masses there. So remember, volume of liquids are going to be in liters and milliliters. Your solids are mainly going to be in cubic centimeters and cubic meters. Cubic meters, cubic centimeters will be your solids. And here we go. With solids, or cubical objects, or even just normal shapes, you're going to be using cubic meters or cubic centimeters. And you find a cubical object is found by taking length times width times height. This is an equation you better remember, you better know. Length times width times height. This equation you better know. Hint, hint, hint. You better know this equation. Hint, hint, hint. Length times width times height. And this is the reason that the unit is cubed. Because if I take centimeters times centimeters times centimeters, it gives you centimeters cubed. If you would do area and do centimeters times centimeters, it equals centimeters squared, just like you've learned in math class. But this length times width times height, because we're taking centimeters times centimeters times centimeters, that's how you get that cubed there. So this should be really easy. You've probably done this before in class. You're just going to be taking the length times the width times the height. Those three measurements right there. Other volumes that you can use, again, these two are the same, length times width times height. But you have volumes of cylinders, volumes of spheres, and a volume of a cone. Now I'm saying cubical object because the most common one you're going to be using is length times width times height. But there are other common volumes, again, like the cylinder, sphere, and cone, that you can use to calculate. Now liquids. Liquids are going to be measured using the unit milliliters or liters. And in this class, when you're measuring the volume of a liquid, you're going to be using a graduated cylinder. And as you can see, there are different sizes to the graduated cylinders, and you saw that earlier this year. But the graduated cylinder is what we're going to be using to measure the volume of liquids accurately and precisely in this class. We aren't using measuring cups. We're going to be using the graduated cylinders. Now, to use the graduated cylinder, when you're measuring it, it's pretty simple, but people make mistakes all the time. The first thing you got to do is pour the liquid in. Pour in the amount of liquid that you need. And this is where we're going to need practice because getting it an accurate measurement with accurately pouring it in is very difficult. And you're going to be using the pipettes that we had in class to get that accurate measurement to help you. But once you get the volume of liquid where you want it to be, you need to read it. And to read it, you got to get eye level with the top of the liquid. Just like it has over here, you got to get eye level with that. If you look down at it or up at it, it's going to be a different measurement than what it actually is. You don't want to look down at it. You don't want to look up at it. You want to get right eye level. So yes, you're going to have to squat down and look at it there. What you're then going to do is read the liquid from the bottom of the meniscus. Now this is like the same type of meniscus, spelling wise, that's in like your knees and stuff. But the meniscus is also called the bubble, and this is your meniscus here. That little bubble here that you're seeing, it forms this little dip because the water is climbing up the sides. You have to read, make sure you read from the bottom of the meniscus. You're reading from down here, not the top. Bottom of the meniscus, not up here at the top. You want to read from the bottom of the meniscus. Some graduated cylinders will give you a meniscus that is more pronounced than others. Some don't give you a meniscus at all. One of the way to help you is to put a note card or a piece of paper or something behind it to block out any of the imagery coming through because of a clear liquid, and it helps you get a better reading there. And sometimes when you put something to block, it allows you to see the meniscus a little bit better. And then after you read from the bottom of the bubble or the bottom of the meniscus, all you're going to do is record your volume to the proper number of decimal places. In this class, the proper number of decimal places is going to be most likely 1 decimal place. You're going to have most of your measurements, or almost all of your measurements, will be in 1 decimal place. So length and mass have 2 decimal places. Volume with our graduated cylinders that we are using in class is going to be 1 decimal place. So reading them again, you have a meniscus here. You have a meniscus, it's forming the bubble here. And we want to read from right here. at the bottom. When you're reading the graduated cylinder, you're just going to basically read it like you would any other measuring device. But you've got to figure out how much each tick mark is worth. That sometimes can be a problem. Some of them go up by 0.2, some of them go up by 0.1. You've got to pay attention to how much each one of these tick marks go up by. Some of them goes up by 1. So in this case, this goes up 20, and we have to 30, so we got to figure out how much each one is. So 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So this one goes up by 1 every time. So we know 20, 21, 22, 23, 24. And because originally, before I drew over it, we see that the liquid stops right on that line, that's why it's 24.0, because it's dead on that line there, or it seems to be dead on that line. When we go over to the next one here, again, we're reading from the meniscus. The meniscus now is in between a line. It's in between, let's see, we got 20 and we're going up to 30. 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So we go up by 1 each time. It's in between 25 and 26. The same way that you have to guesstimate on a metric stick, you're going to have to guesstimate in between. To me, it looks like it's closer to the 6 instead of halfway. So I'm going to say 25.8 milliliters. You will get some playroom with this, but again, the same way on a meter stick where the lines are very, very close together in an actual meter stick, the lines are very, very close together on an actual graduated cylinder. So it is a little harder to read, but you'll get practice with that. Now the final way to measure volume. So we have volume of a cubical object, length times width times height, volume of liquids using the graduated cylinder, and now we have the volume of an irregularly shaped object. Irregularly shaped object, so something you can't easily measure the volume of. Usually it can be something that's not length times width times height. Real simple, real basic. We're going to use something called water displacement. Water displacement. Some people even call this the Archimedes principle, where you see Archimedes was a gentleman, and you go look him up. He was charged with finding the volume of a king's crown. He got into the bathtub, the water rose, and he realized the water rose the same amount that he got into the bathtub, which is water displacement. And we're going to be using this for regularly shaped objects, and you're going to be measuring them in milliliters again, because we're using the graduated cylinders and they have milliliters. But you can easily convert this back into cubic centimeters because of the 1-to-1 ratio here. They're the same thing. So if you have 30 milliliter object, you have 30 cubic centimeter object. So with water displacement, what you do is put an amount of water in the graduated cylinder. That is going to be your initial volume, VI. I standing for initial, V standing for volume. So we put water in here, and we got 4.0 milliliters. Then you're going to add the objects to the graduated cylinder, and we'll go over how to do that in class so nothing splashes out. 3, after you add the objects, the water is going to rise. You're going to read this new volume here, and I have a mistake here. This should be VF on here. It's correct down here, but this here should be VF for V final. Your VF is where the water is after adding the objects. Read the volume. After you have the two volumes, you're going to subtract. So VF minus VI. VF minus VI. When you do that, you're going to have here in this example 6.0 milliliters minus 4.0 milliliters. That's going to give you the volume of your object, VO. That means those two spheres in there have a combined volume of 2 milliliters. That difference, the difference is your VO. So the difference is going to be your final volume, or the volume of your object. So those are the three ways to measure volume. You can now see the units that we use to measure the volume in class. If you have any questions, please feel free to contact me. Thank you, everybody, and have a wonderful day.